Hello, we will explain equations and inequalities today. I will explain equations and Adi will be explaining inequalities. I will start with the equations and he will continue with inequalities. The mathematical representation of two equal quantities involving one or more variables is called an equation. And the symbol, this is used in the representation of equations. For example, 4x plus 6 equals 18 and 3x minus 5 equals 16. Now let's solve these examples. To solve an equation, we need to leave variable alone. To leave the variable alone, we can use addition, subtraction, multiplication and division. We need to leave 4x alone. To do that, we have to subtract 6 from each side. If we do that, we get 4x equals 12. Now, x is a coefficient. We still have to leave x alone, so we have to divide both sides by 4. When we do that, we get the result, x equals 3. Let's do the another one. We still have to leave x alone, so we have to add 5 to each side. If we do that, we get 3x equals 21. And now we have to divide each side by 3 in order to leave x alone. Then we will get the result, x equals 7 if you divide each side by 3. And this is how you solve equations basically. Now let's continue reading. The degree of an equation is determined by the power of the variable. In these equations, the degree of the variable is 1. We don't write 1 because it doesn't change anything. The equations which can be expressed as ax plus b equals 0 are called linear equations in one variable. A here is the coefficient of the variable, x is the variable itself, and this is the equality symbol as we said here. For example, 3x minus 7 equals 0 is a linear equation in one variable. Let's solve some questions. First, if the equations 2x minus 2 equals 10 and 2x minus a equals 7 have the same solution set, find the value of a. We add 2 to each side and then we get 2x equals 12. Then we divide each side by 2 in order to get the result of x. X equals 6. So the solution set of both equations should be 6. Now let's solve the second equation. We should leave x alone, so we add a to each side. Then we get 2x equals 7 plus a. We need a number that makes this side 12, because when we divide it by 2, we should get a 6. So the number is 5 here, because if we add 5, it will become 2x equals 12. And if we divide it by 2, x will be equal to 6 once again. So this is this result of the question, a equals 5. And let's solve the last question of today. Find the solution sets of the following equations in real numbers. Let's start with a. As we learned previously, we have to leave the variable alone itself. Let's start. So we have to add 8 to both sides to leave 6x alone. So let's do it. Then we get 6x equals 18. Then we should divide both sides by 6 because 6 is the coefficient of the variable, so we have to get rid of it. And then if we do it, we get x as 3, and that's the answer of the first question. In part B, we have to get rid of two things, minus 5 and minus x. Let's start with minus 5. We have to add 5 to each side to get rid of minus 5. And if we do it, we get 2x equals 11 minus x. And for the question, we have to get rid of one more thing. That's the minus x. So we have to add x to both sides. And the result, 3x equals 11. then we should leave x alone. So you have to divide both sides by 3. And if we do it, we get x equals 11 divided by 3. And that's a fraction, and the question told us to find the answers in real numbers. So fractions include real numbers or real. The question is a bit tricky because it has an answer that we're not familiar with. And let's start. As you know, we have to get rid of 2x because we have to leave variables alone. But if we get rid of 2x, we will have to subtract 2x from both sides. But if we do, we get something like this. 7 equals minus 3. And that's wrong. So this question's solution set equals an empty set. Second question. Find the solution set of the following equations in integers and in real numbers. A. 3 divided by 4x plus 2 equals 3. Now we should divide this with this. To be able to make addition in fractions, we have to equalize the denominators. So if we equalize denominators, we get this. And multiply 2 with 4, we get 8 divided by 4 equals still 3. Now we should add them up. We do it like that. 3x plus 8 divided by 4. We don't write them twice, we just write them in one equation. Equals 3. Now we should equalize denominators again. If we write 4 here, we should multiply this number by 4 and we get this. Now we can get rid of the denominators and just write this. 3x plus 8 equals 12. Now we know what to do. We should subtract 8 from each side and we get 3x equals 4. Then divide each side by 3 and we get x equals 4 divided by 3. And that's the result of the first question. Now let's solve the second question. 3 minus 3x plus 4 equals minus parentheses x plus 2 close parentheses plus 5x. Now we should use the technique of distribution here. How we do that is we distribute the symbol to each variable in the parentheses. Then we get something like this if we do that. Minus x and minus 2 because minus is dominant plus 5x. Now we should add the same elements up. There is nothing to be added here, but the other side we should add up minus x and 5x and we get 4x as a result. Then we have minus 3. Now that's quite challenging, this part. In this part we should get rid of minus 2 and minus 3x. Let's start with minus 2. We should add 2 to each side and the result is minus 3x plus 6 because we add plus 2 equals 4x. Now we still have something to get rid of, and that is that. But how do we do that? By adding 3x to both. By adding 3 to each side, we will have 6 here, and on the other side we will have 7x. Now it's the easy part of the question. We just have to divide each side by 7, and if we do that, we get x as 6 divided by 7, and that's the end of the question. There is one last thing to do. The question told us to find the answers in integers and real numbers. In the first question, there is no problem because 4 is both an integer and a real number. But in the second question, the result was 6 divided by 7. Integers doesn't include fractions, but real numbers do. So according to integers, the result is an empty set. But according to real numbers, the result is 6 divided by 7.
Hello guys, today I'm going to talk about inequalities. Inequality is an expression which shows that a quantity is more than or less than another quantity is called an inequality. Less than or equal to, bigger than or equal to symbols are used in representation of inequalities. In the half open intervals, we use one square bracket and one round bracket, as we can see in this example. It doesn't matter where we use the square bracket or the round bracket. We can use them in the beginning or at the end of it. Like x plus 1 is less than 19. So, what should we do? We should send plus 1 to the other side of the inequality. And it will be x is less than 18. And that's our answer. So, let's look at less than or equal to symbol. So, let's start with an example. 2x plus 6 is less than or equal to minus 8. First, we should send 6 to the other side of the equation. 2x is less than or equal to minus 14. So 2x is less than or equal to minus 14 and x is less than or equal to minus 7. So that's the answer. So let's solve another example. 3x plus 9 is less than or equal to 14. Again, first we send 9 to the other side of the inequality. It's 3x is less than or equal to 5. So, if you want to find x, we should divide both sides to 3. And the answer is x is less than or equal to 5 divided by 3. So, let's look at greater than. First, let's start with an easy example. If we have 10 and 5, 10 is greater than 5. If we have 1000 and 100, 1000 is greater than 100. So, let's look at some more difficult examples. 3x plus 5 is greater than 100. So, first we send plus 5 to the other side of the inequality. 3x is greater than 95. If we want to find x, we should divide both sides by 3. And that's x is greater than 95 divided by 3. That is our answer. So, let's look at greater than or equal to. So let's start with an example. 2x plus 6 is greater or equal to 8. Again, first we send plus 6 to the other side of the inequality, and that's 2x is greater than or equal to 2, and x is greater than or equal to 1. So that's the answer. So let's go on with another example. 3x plus 5 is greater than or equal to 19. Again, we send 5 to the other side of the inequality, and 3x is greater than or equal to 14, and x is greater than or equal to 14 divided by 3. So, after we learned the symbols that we use to show inequalities, now let's move on to intervals. Intervals are the totality of points on a line between two designated points or endpoints that may or may not be included. There are three types of intervals: closed intervals, open intervals, half-open intervals. So, let's learn our new terms by giving some examples. This is a way to show intervals. This bracket is called square bracket. We use square brackets when we want to include a number near to it. And this is a round bracket. We use round brackets when we don't want to include the number near the bracket. After we learn new terms about intervals, we can go back to the three types of intervals. The first one, the closed one, we use two square brackets, in the first and in the end. This means we include both the first and the last number. In the second one, the open one, we use round brackets on the both sides, and this means we do not include the first and the last number. So, let's look at some more detailed examples about three types of intervals. These are all called the representation of the intervals on the number lines. So this is an example for the closed interval. You can see both of the dots are filled. So this representation also means 5 is less or equal to x is less or equal to 8. In the open interval, you can see both of the dots are not filled. So we can simply say 5 is less than x is less than 8. In the half-open intervals, there are two types of representation that depends on the inequality. The first one is the first dot is not filled and the second dot is filled. This means 5 is less than x is less than or equal to 8. And in the second one, it's in the opposite way. 5 is less than or equal to x is less than 8. So this is the end of the interval topic.